Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, because this is, after all, Ask the Expert, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. Thank you for joining us today. It is now my pleasure to introduce our speaker, James Brook from BD.
Thank you, Leah. Hello, everyone, and welcome to our broadcast, our webcast today. Thank you for attending. My name is James Brooks. I'm an R&D Manager with BD Biosciences, Advanced Bioprocessing. My topic today is going to be cell culture media supplementation. More specifically, looking at the effect of peptones and CD supplements on culture performance and protein quality. So by way of background, just a little information. So in the recent years, or even more extensive years, a lot of effort's been put into improving the bioprocess through the improvements in multiple aspects, including cell culture media. And significant productivity gains have been achieved through the evolution of cell culture media, where today multigram per liter titers are common, with double-digit titers being reported in some instances. With the achievement of good enough titers, the primary focus now is shifting more so to monoclonal antibody quality. One driver of this is the increasing number of biosimilars in the global development pipeline, with over 500 different biosimilars currently in development on a global scale. So, suboptimal media and supplement formulations can detrimentally impact culture performance and protein quality. Along with improvements in cell culture media, central to that has been evolution and improvements in cell culture supplementation. In the pre-1990s, serum supplementation was almost exclusively used for mammalian cell culture. As we all know, lots of lot variability, supply issues, and risk from adventitious agents and other contaminants impact serum, and peptones at that point were being used almost exclusively for microbial cell culture. Into the 1990s, with an enhanced risk reduction need, peptones began to be used as a rapid solution to deliver titer without affecting protein quality in mammalian cell culture. And in fact, the development of many of today's blockbuster drugs occurred during that time using peptone supplementation. The drive for more improved consistency has led to a desire for chemically defined media formulations. And this has also resulted for some variability with different lots of peptones. Whereas today, although chemically defined formulations are still ultimately desired, there has been a rekindled interest in peptones as supplements, and this, again, is particularly of interest in the area of biosimilar development. And partly contributing to this has been the fact that CD media don't always deliver the desired titer or protein quality. This slide just shows a few examples illustrating that last point, where either limitations in cell culture media formulations or impurities can impact the overall performance and product quality. These could be trace element impurities such as manganese, or the improper concentrations of copper, or limitations in components such as amino acids, tyrosine, that can overall impact both the performance and the protein quality of monoclonal antibody production. So both peptones and CD supplements are viable options when you're considering supplementation, but it's important to understand the characteristics of each and what they bring to the cell culture process. Peptones primarily serve as nutritional buffers. They have a wide variety of components, but beyond nutritional, they can also impact the cell culture, serving as buffers from toxic agents. They've also been shown to affect cell cycle. They've been shown to suppress apoptosis in cultures, overall having an effect of enhancing cell density, viability, or titer. And as I previously mentioned, there can be a rapid, low-cost solution to enhance the overall process. Similarly, CD supplements can enhance densities, viability, and titer as well. But CD supplements typically provide only the essential culture stimulators. They have fully defined components but a more limited composition. So when deciding which of these is right for your particular process, it's important to understand what the process needs, what drives your process, and what each of these can contribute. So with that being said, I want to go through two brief case studies to show you how we at BD have used both Peptones and CD supplements to address both performance and protein quality needs in projects we worked on with different customers. This first case study illustrates a customer developing a biosimilar monoclonal antibody where they needed to match the protein quality, in this case defined by charge variant of the originator molecule. In this case, we developed both multiple CD and peptone-containing media, and we analyzed those for growth and production initially, and then those lead formulations were selected for charge variant profile analysis. The panel on the upper left shows the overall growth, VCD, and production generated for 3 different CD media that we evaluated. And you can see different levels of growth, different levels of production depending upon the particular CD media formulation. Likewise, on the right, you see 4 different peptone media that were similarly evaluated, and you can see different levels of growth and production detected in those media. But importantly, we had growth and productivity targets, but the overall desire was to match the originator molecule for charge variant profile. As you can see of the CD media on the lower left, 2 of the 3 media that we looked at actually have profiles very close to that seen with the desired profile of the originator molecule. Likewise, with the peptone-containing media, 3 of the 4 media gave us good growth and protein production. Those were analyzed for charge variant, and you can see 2 of those 3 gave us very good profiles similar to that seen with the originator molecule. So in this case, both CD and peptone-containing media were identified which gave us the correct charge variant profiles. However, in this particular case, for the cell line and process of interest, the peptone-containing media actually gave us the desired growth and production targets, so that's what we ended up moving forward with. And my second case study is an illustration of a project where we worked with a customer to move from a commercial media formulation, CD media formulation, to a proprietary CD or peptone supplemented media. But the customer wanted to increase their production at least 100%, and at the same time they had a very short time frame and needed this media very quickly. So our approach was to run a parallel media screen where we screened our proprietary CD media library and peptone media library to look for hits for this particular cell line. And you can see in the upper panels the CD media library screen on the left, peptone media library screen on the right, the ranking by % production for each of the media included in the screen and the differential productivity that we saw both for the CD media and for the peptone media. That was done in deep well plates. We selected several of those media and moved forward and scaled up into shake flask culture to further evaluate performance. And we're showing just a few of those media that were scaled up here in the bottom panels. On the left, you can see that we have 3 different media, CD media 12, 28, and 39, that were scaled up into shake flask. And at this point, none of these media meet our desired 100% increase over the productivity we're seeing with the control. However, the peptone-containing media that were scaled up, 28, 26, 6, and 25, we can see even at this early stage from just the initial screen, we have definitely 2 or possibly 3 of the media that are meeting our desired increase in productivity from just the initial screen of our peptone library. So we saw the production goal was achieved very quickly in the peptone supplemented media in this case, but the CD media showed some improvement. You can see over the control here, especially for CD medium 12, but the CD medium required additional optimization. So we moved forward also. We had the peptone media 28 that worked well, but we also had CD medium 12 and moved forward to do some additional enhancement of that CD medium through the modification of additional CD components and classes of components. What's shown here is a result of this base medium enhancement. So we have the media from the screen, CD medium 12, we have our control, and then we have 10 different versions of CD medium 12 that were further enhanced through the modification of components. Again, deep well plate screen showing a ranking of production based on % of control. We selected several of those media, scaled them up again to shake flask, and you can see at this point we have our control, designated at 100% production. We have our original CD medium 12 from our screen, not quite achieving our production goal, and then the 3 enhanced versions of CD medium 12, which meet and exceed the production target of 100% increase. So this slide just summarizes the overall project where we ended up from start to finish. You can see our control medium and level production. With the CD medium initially, we got a nice enhancement but still didn't meet our target. And further optimization of the CD medium actually met the target and exceeded the production target. This is outlined here at the bottom of the schematic on the right, where we did the screen, we did the enhancement, and finally achieved the goal. This overall process took about 10 to 12 weeks. You can see also with the Peptone Media 28, very quickly, as depicted on the upper right here, just in our screen and scale up, we're able to identify a medium that achieved the goal, which took about 6 weeks. Medium 28, we were able to exceed the desired target in a very quick time. So both Peptone and CD supplementation achieved the production goal. Peptone supplementation was more rapid, as I mentioned, about half the time. And additional optimization was required for this particular CD medium. We were able to ultimately achieve our goal, but we did have to do additional enhancement and optimization of the formulation. So just a few conclusions from the information I've gone over. The cell culture media and supplementation continue to be critical elements. There have been great achievements in titer and productivity levels, but they still are areas of focus to increase titer and also modulate protein quality. Peptones and CD supplements can differentially affect each of those parameters, but they are also viable options, both of them, for the overall bioprocess. And finally, a very important point, knowing the drivers of your culture processes is key to identifying what the appropriate supplements should be. Thank you very much, and I'll be happy to take any questions.
Thank you very much, James. And as a reminder, you can type your questions into the chat window. So our first question is, how do we find out what is driving our cell culture process? And once we know these drivers, what is the best way to identify which hydrolysates and or supplements will have a positive impact on improving our processes?
Very good question. First of all, it's important to consider there are multiple components affecting your overall cell culture process, not only the media and the supplement, but the cell line, importantly, and also the process parameters such as the reactor, if it's a fed batch process, the feed timing, feed strategy. A lot of different things can influence the overall cell culture process. But more specifically around the cell line and the media, it's important to also realize that each cell line is unique. It has different requirements, nutritional and otherwise. In fact, in our hands in customer projects, we've worked on different cells coming from the same parental, so different sister cell clones that have been very different in their nutritional requirements. So although you may have a CHO cell line, it may not perform exactly like another CHO cell line that you've worked with or your neighbor's CHO cell line. But as related to specifically to cell culture media and supplements, I would recommend initially doing a very comprehensive spent media analysis, doing analytical testing to look at the components, the utilization of components in the media, the generation of byproducts in the media, to understand exactly what's driving your cell's performance and what should be addressed through supplementation. I think once you have that information, then you can move forward in understanding and selecting the best hydrolysates or supplements that can have a positive impact. I think definitely there's information, although peptones are not fully chemically defined, there's a lot of information available around their composition, a lot of analytical data. I know we here at BD have done this extensive analytical analysis of our peptones to know quite a bit about their composition and makeup. So with those two factors in mind, then you can better pair the right supplement to the cell culture process.
And what about lot-to-lot variability in peptone raw materials? How do you handle that? Are peptones more variable than CD supplements?
Well, I think that's been the thought, is that I want to move away from peptones because they're inherently variable, and if I move to a chemically defined component, then I'm going to have less risk and less variability. As I mentioned, we're hearing more instances about where chemically defined components can have impurities, so they're not necessarily fully defined. But I think, yes, it is important to recognize that peptones are not fully chemically defined. However, especially we here at BD, we take a lot of steps to make sure in our manufacture, our release of our peptones, that we're controlling aspects of peptone production, and that our peptones are being developed for application in mammalian cell culture. So it's important to make sure that you understand, again, what's driving your process and how those peptones or those CD supplements can fit in.
And did you see any influence during harvesting depending on the different media?
I'm sorry, could you repeat the question?
Did you see any influence during harvesting depending on the different media?
No, we didn't have any different influence. I think, looking at the different case studies that I presented, I think both CD and peptone options were satisfactory to give us the overall protein production and titer. But as far as any harvesting, there were no issues around that.
Can you tell us the source of the peptones you use?
The source of the peptones that we use? Well, typically, there's a wide range of peptones available in the market, and we've worked with, primarily BD peptones, but we do work with a diverse array of peptones, both animal origin and animal free. We typically work with multiple bases and, use primarily animal free components, yeast, soy, and others.
And there's been a large push toward completely chemically defined systems in the past 5 years. When is it best to supplement chemically defined processes with hydrolysates?
Well, I think a major consideration for whether to use hydrolysates or not can be the overall time frame. As I mentioned, one project that we worked on, the second case study, had a very short time frame, and as you saw, it took a bit longer to achieve the CD version of the media to give the overall production target. So I think that's one consideration. If a rapid solution is needed, hydrolysates can often provide that solution in a very easy, quick fashion. Otherwise, I think it's best to understand, again, the process. I think it's important to know what's driving your cells, and then make sure to match the appropriate hydrolysate supplement. So I think if you're seeing issues as are becoming more and more common in the industry where CD supplements may not be giving the overall titer, they may be affecting protein quality, then it's time to consider looking at hydrolysate options, especially animal-free hydrolysates. There's a lot of good hydrolysates out there, and as I said, we specifically develop and our particular hydrolysates for application in the cell culture market.
Okay. I'm going to ask one final question. Thank you for all your questions. There's a couple we haven't gotten to, and we will go ahead and pass those along to James to follow up with you individually. The final question is, how about the feeding time? Does it affect like a zero inoculation time or after?
Feeding time can have an effect. I think in these cases, the data I showed you were all batch culture, but we do know that variation in feeding time, feeding regimens, can enhance, can affect protein production, titer, can also have effects on protein quality. So again, that's another aspect of the cell culture process that needs to be understood. As I mentioned, the cell line definitely itself, the media and supplementation being used, but also the feed, not only the feed, but the feed regimen and strategy as well.
Thank you very much, James, and thank you all for joining us. We will get back to you with the questions at the end in the follow-up email. Thank you.